Good day everyone, welcome to another video lecture series as a continuation for our discussion on theorems on derivatives. Okay, so today's discussion would cover two of the most important techniques of differentiation. One for composite functions that are in the form of terms that are multiplied together, and the other one is the form of the composite function wherein the form is of the form of a fraction. Okay, so we refer to them individually as the derivative of a product. So of the form h of x is equal to f of x times g of x, and the other one is the derivative of a quotient, wherein the form is h of x is equal to f of x over g of x. Of course, these are real valued functions, so these are continuous functions. So this means that the derivatives and the limits of these functions are assumed to exist, so that we can perform the actual process of differentiation. Okay, so let's try to have the first one, the first theorem, which is the derivative of a product. Again, the form of the derivative of a product is you have h of x, which is equal to f of x times g of x. So, in translation, if you have algebraic forms, f of x is a distinct algebraic form, and g of x is the same, is a distinct algebraic form of the given function. Then, the derivative of h of x, which is h prime of x, is equal to this form. Now, try to notice you have f of x times g prime of x, or the derivative of g of x, plus the derivative of the first form, first function, f of x, times g of x. Now, perhaps to shorten the notation, let's try to make use of certain notations so that we could shorten our reference to our derivative of a product. So let's try to say, let f of x be our first and our g of x as our second function. So f of x is first, g of x is second. So if you have h of x is equal to first times second, h prime of x would be first derivative of second plus second g of x times derivative of first. Okay, so derivative of h prime of x, derivative of h of x is equal to f of x times derivative of g of x plus derivative of f of x times g of x. Now, of course, just like any skill, in order for us to fully appreciate this technique, let us try to perhaps apply this technique to certain examples. So let's try to have this example number 1. Okay, as we can see, that our first is the form x plus 1. Our second is the form x squared plus 1. So just like before, so what we can, just like what is illustrated in the theorem, if you have h of x is equal to first times second, the derivative of h of x is first derivative of second plus second derivative of the first. So try to writing that one in perhaps a longhand notation. We could have the following form, no? Okay, so let's try to write this in a familiar notation. So we have f prime of x as the derivative of x is equal to the derivative of the first, first derivative of second. Okay, so let me write that again. Okay, so you have f prime of x is equal to first derivative of second, so meaning you just copy the first form times the derivative of the second form plus first derivative of second plus second derivative of the first. So plus second, meaning we just need to copy the second form, times the derivative of the first. Right. Now take note of the notation. The subscript x refers to the derivative. The derivative of the function that appears after. So let me just adjust few of the terms. Okay, so again, f prime of x would be equal to first derivative of the second plus second derivative of the first. So after which we now perform the actual equivalent of this initial form of the derivative. Okay, so applying the previous theorems on simplification of the derivatives, we try to come up with the simplified form of the initial step. So again, we have the form of f prime of x as first derivative of second, meaning the first expression would just be copied. So x plus 1 times the derivative of the second. The second form is x squared plus 1. So performing the derivative of x squared, that becomes 2x raised to 1, then plus 0, since 1 here is a constant, plus, copy the second, so you have x squared plus 1 times the derivative of this form, x plus 1. So since x here is x raised to 1, 1 minus 1, then plus 0. Okay, so let me just clarify that part. So you have x squared plus 1 times the derivative of the second, so you have x raised to 1 minus 1, then plus 0. Okay, so let's try to insert this in our document. Okay, so to simplify things further, we have finally x plus 1 times, of course, 2x raised to 1. X raised to 1 here is simply x. So we no longer need to write down x raised to 1. It's understood, and it's also understood that plus 0, we could remove the plus 0 in the expression. Also, you have x raised to 1 minus 1 is equal to 0, so that leaves leaves x raised to 0 only, and of course the plus 0 would disappear, and also x raised to 0 is equal to 1. That means eventually we could leave this everything behind and remove it entirely from our expression, since this becomes 1, and 1 here times this everything here is equal to itself, x squared plus 1. So yeah, we could simply remove this part. Now, as a final form of the answer, we could actually perform the product between 2x times x, distribute 2x with x plus 1, and perhaps drop the parentheses and combine like terms. So if we are going to multiply 2x with x, that becomes okay, multiplying 2x with x, okay, so this becomes that would become 2x squared plus okay, so let me just repeat that part. Okay, so we have 2x squared. 2x times x is 2x squared, plus 2x times 1 is 2x. And let's just drop the parentheses, then continue with plus x squared plus 1. Okay, so this is actually part of f prime of x. Okay, so combining like terms, that would give us now, of course, 2x squared plus x squared would add up, so that becomes 2 plus 1, that becomes 3x squared. So let's just remove the x squared part here. And 2x has no partner, and 1 also has no partner, so therefore, we will be left with this final form of the answer. We have f prime of x as the derivative of x plus 1 times x squared plus 1. That would be equal to 3x squared plus 2x plus 1. Okay, so let's have example number 2. Okay, so for example number 2, this is also considered as a derivative of a product, since obviously the composition of our g of x is made up of two distinct terms. So we have 1 plus square root of x and 1 minus 2x. Okay, so first let's try to rewrite the square root of x using its form in the form of a number that has its roots equal to fractional exponent. So we write g of x is equal to, that would become 1 plus x raised to 1/2 and times 1 minus 2x. Okay, so perhaps we could okay, so again x is raised to 1/2. Okay, so perhaps we just clear this out. This becomes raised to 1/2. Alright. Before doing actually the actual process of differentiation, again, the differentiation process for the derivative of a product goes with the first expression would be referred to as the first, and the second expression would be referred to as the second. So just like the theorem says, the derivative of a product is first derivative of second plus second derivative of the first. Okay, so performing this process for g prime of x for number 2, we have okay, so we have g prime of x is equal to first, meaning we just copy the first expression multiplied by the derivative of the second expression okay, so perhaps we could write this in the derivative form. Okay, so times the derivative of the second, so 1 minus 2x plus second derivative of the first plus second, so meaning 1 minus 2x times the derivative of the first, so 1 plus x raised to 1/2. Okay, so let's try to insert this first in our document. Okay, so again, g prime of x is first derivative, first derivative of the second plus second I'm just trying to clean this up, plus derivative of the first. Okay, so let's try now to perform the actual process of differentiation. So what happens here now is you have the derivative of 1 minus 2x is obviously the derivative of 1 is 0 minus the derivative of 2x is equal to negative 2, since what happens to x here is that x becomes raised to 1 minus 1, that would be equal to 0, just like what we have seen here previously in the first example. You have x raised to 1, 1 minus 1 becomes 0, and any number raised to 0 becomes 1. So basically what happens here is when you perform the derivative is that negative 2x here becomes negative 2x raised to 0, and x raised to 0 is 1. 1 times negative 2 becomes negative 2. So basically what happens here is that this becomes equal to negative 2. Right? Again, if you haven't caught that, try to review the YouTube video so that you could actually follow the step-by-step solution. Okay, so we're done with the first part. Now proceeding to the second part, we have 1 minus 2x times the derivative of this part. Okay, so for this one, we have derivative of 1 would be equal to 0, since 1 is a constant. And again, you have x raised to non-zero exponent, so you have 1/2. So what we do with the non-zero exponent is that we bring that non-zero exponent beside our x, just like what you see in the video, what you see here. And what we do with the exponent after is that we subtract 1 from that. Now, of course, what happens here is you have 1/2 minus 1. 1/2 minus 1 is, of course, negative 1/2. Then this would result into the final form of the derivative of this part. Okay, so remember this part here, 1/2 x raised to negative 1/2, is the result of the derivative of this highlighted portion. This result is the first derivative of the second plus second derivative of the first. Okay? Now, to simplify things further, we could do some distribution. So we can have negative 2 times 1, that becomes negative 2. And we also can do distribute negative 2 to both. So we have negative 2 minus negative 2x raised to 1/2. So, and dropping out the parentheses. So we can have this part removed and basically remove the parentheses. As for the second part, this part here, we can distribute this part with both 1 and negative 2x. So 1/2 x raised to negative 1/2 times 1 becomes itself okay, so this becomes the part of 1 times 1/2 x raised to negative 1/2. And for the second part is that you have negative 2x times 1/2 x raised to negative 1/2. So basically you have negative 2 divided by negative 2. This cancels out the 2, which means you will no longer have 1/2 in this expression. What is left now here is you have negative x times x raised to negative 1/2. Of course, x raised to nothing is understood as x raised to 1. So which means you eventually, by applying the laws of exponents, you will be adding up 1 with 1/2. Again, to write that one, since this is negative, this means that if we remove the parentheses, this becomes no longer plus but minus. And what happens to the deleted x is that this combines with x raised to negative 1 half by specifying that x becomes 1 minus 1 half. Now x raised to 1 minus 1 half. 1 minus 1 half is of course positive 1 half. So finally, by removing further the parentheses, we have x raised to positive 1 half. Okay, so to further simplify this part, we could combine like terms. So obviously, negative 2 doesn't have any like terms in the expression. There are only two terms. You have negative 2 x raised to 1 half and negative x raised to 1 half as similar terms. So we could combine these two. So this is basically negative 2 minus 1. So negative 2 minus 1 is equal to negative 3. So this becomes finally is g prime of x is equal to negative 2, negative 3 x raised to 1 half plus 1 half x raised to negative 1 half. This would serve as the derivative of the of our original product 1 plus square root of x times 1 minus 2x. Okay, so let's now proceed with the derivative of a quotient. Now, the derivative of a quotient, we have the following formula for supplying the derivative of the quotient. So the form of the quotient should be in the form of h of x is equal to f of x over g of x. Of course, the condition is that g of x should not be equal to 0, otherwise the form of the fraction h of x would be undefined. So it is necessary that g of x is not equal to 0. Now, as for the derivative of the quotient of the form f of x over g of x, h prime of x would now be equal to. Now, before we proceed, let us refer to f of x as the high part since it's the numerator of the fraction. G of x would be the low part since it's the denominator of the fraction. Then we refer to high and low. H prime of x is equal to low derivative of high minus high derivative of low over the square of low. So, or in actual terms, h prime of x is equal to the derivative of the denominator function. Times g of x, g of x times f prime of x minus f of x times g prime of x over the square of g of x. Okay, so again, perhaps we could establish how we perform the derivative of a quotient by applying it through given examples. So let's have the first one, the third one, number 3 in our list of examples. So we have h of x is equal to 1 plus x over x. So obviously, this is a form of a quotient wherein our f of x is supplied by 1 plus x in our given form. Okay, and g of x is of course is equal to x. Now, let's do the actual derivative. Now, the derivative of a quotient again is given by okay, so h prime of x is equal to, this becomes low times derivative of high minus high derivative of low all over low square. Alright. Okay, so let's try to insert this one and clear up the unclear part. So we have this is h prime of x as the derivative of h of x is equal to the low derivative of high. The derivative of high is let's try to copy the okay, so perhaps low derivative of high, derivative of 1 plus x. This becomes minus, this becomes high, then derivative of low, derivative of x over low square. So this is actually low square. Okay, so next step is to apply the portions in our solution for getting the actual derivative of that form of the function. Okay, so again, let's try to write this in the form of, we have h prime of x is equal to, again, the numerator is x times the derivative of 1 plus x, the derivative of 1 here is 0, so plus derivative of x is equal to 1, so basically this is equal to 1 times x is x, minus, this is 1 plus x times, the derivative of x here is equal to 1, so times, basically this is times 1, all over x squared. Okay, so let's try to insert this in our document. So we have, again, you have h prime of x is equal to first derivative of low derivative of I. So derivative of 1 plus x is derivative of 1 is 0, derivative of x is 1, so this is basically 1. 1 times x is obviously x. Next is minus high derivative of low derivative of x is equal to 1, so that becomes 1. Since this is only times 1, so we could remove that part and perhaps distribute negative to both 1 and x. That makes it negative times 1 is negative 1, and negative times x is negative x. So here we go. Okay, so next would be to combine like terms. We now have, obviously, you have x minus x, that is x would cancel out, so that means what is left is negative 1 over x squared. We could write actually this fraction form as is, as you can see here, or we could bring down or take the negative sign outside of the fraction sign, and let's just write 1 there, so 1 over x squared, and the negative goes out here in the fraction. So finally we have h prime of x as equal to negative 1 over x squared. Okay, so perhaps we could try another example. So let's try to have number 6, since this is a quotient. If you cannot see that this is a quotient, perhaps you could see better if we could rewrite this in this form. Now, of course, 2x minus 1 raised to negative 1, if you try to take the reciprocal of this, then this means that this is actually should appear in the denominator. And if it appears now in the denominator, then we can simply remove the negative 1. So what is left now here is simply 3x squared plus x in the numerator, and you have 2x minus 1 in the denominator. Now, proceeding now with getting the derivative. Okay, so let's have g prime of x Okay, so you have g prime of x is equal to low, so meaning 2x minus 1, derivative of high, 3x cubed plus x minus low derivative of high minus high, 3x cubed plus x times derivative of low. Derivative of low is derivative of 2x minus 1. Okay, so all over the square of low. Alright, so let's try to insert this one. Okay, so let's perhaps clean this up first. Okay, so again, 2x minus 1 is low, 3x cubed plus x is high, so the derivative of the quotient is low derivative of high minus high derivative of low over low square. Okay, so the next step in our performance of the differentiation is we perform the differentiation of the parts wherein we apply the process of differentiation. So at this part, we have the derivative of 3x cubed is actually the derivative of 3x cubed is okay, the derivative of 3x cubed, that would be 9x squared plus derivative of x is equal to 1. Okay, so let's have this in parenthesis form. And let's try to insert it in as part of the equation. Okay, so 9x squared plus 1 minus 3x cubed plus x times the derivative of 2x minus 1, this part here. So derivative of 2x is equal to 2. Okay, so that will be 2. Derivative of 2x is 2. Derivative of negative 1 is 0. So simply what is meant here by the derivative of the low part is basically equal to 2 only. So let's try to replace that with 2. So this is multiplied by 2 over square of 2x minus 1, 2x minus 1. Okay, so the next step is to have a replacement for the simplified form of the rest of the fraction. Okay, so let's try to simplify first 2x minus 1 with 9x squared plus 1. Okay, so for this part, we just make use of the FOIL method. So for the FOIL method, we have okay, so the first one is you have 9x squared times 2x. Of course, 9 times 2 gives you 18. Next is you have x squared times x, that would be x cubed. Okay, so let's try to clean this up first. Okay, so this becomes 18. Okay, so 18x cubed. Next is you have 9x squared times negative 1, so that becomes negative 9x squared. Next is 1 times 2x, that gives us 2x, so plus 2x. Then negative 1 times 1, that gives us negative 1. Alright? So that's part of the equation becomes this one. 18x cubed minus 9x squared minus plus 2x minus 1. Now for this part of the solution, you have to distribute 2 with 3x squared. Okay, so that becomes 3x cubed times 2, that becomes 6x cubed. Then plus 2 times x, that gives you 2x. Alright? And let's try to write this in parenthesis form. Okay, so insert that here. Okay, so from here, what we can further do is to remove the parentheses by distributing the precedent sign. So in the case of this part, we just simply remove the parentheses. As for the second part, we need to distribute negative to both of these two terms. So what happens now to our expression is this becomes, okay, so for this part, we simply drop the parentheses. As for this part here, we need to distribute the negative sign to both 6x cubed, so that becomes negative times positive, and negative times positive is also negative. Okay, from which we can now simplify further by adding like terms. So this basically becomes, well, this 18x cubed, of course, combining that with negative 6x cubed. So you have 18 minus 6, that gives you 12x cubed. Okay, so let's just remove negative 6x cubed. As for 9x squared, it doesn't have any similar terms. We have also 2x positive and negative 2x, so this 2 would cancel out. So finally, we have this form, 12x cubed minus 9x squared minus 1 over 2x minus 1 squared. Now, if you try to notice, we can no longer have any further simplification for this part, so which means our final answer for the derivative of the quotient of this expression here is this one. Okay, so perhaps we could try another example. So let's try number 8 here. Okay, so m of x is equal to the numerator is composed of a fraction, an expression. This makes it more complicated. So okay, so perhaps you could try this one. I could give you this one as an example. So again, our quotient part is that this expression here would be our low, and the entire numerator would be our high. Okay, so let's try to write first the basic expression for m prime of x. So m prime of x is equal to low plus x minus 2, then derivative of high, derivative of x minus 1 over x plus 1 minus high, meaning x minus 1, x plus 1, derivative of low, derivative of x squared plus x minus 2 all over everything low square. So you have x squared plus x minus 2 and square. Okay, so this would serve as our basic form. Okay, so let's try to insert that. Okay, so you have m prime of x, m prime of x. Again, this is low derivative of high minus high derivative of low over low square. Now, as for performing the derivative of those portion that has derivative, such as this one, try to notice that this is of quotient form. So, which means that we're going to apply again the quotient form the second time, but only for this part of the derivative. Okay, so rendering that our x minus 1 would be our high and our x plus 1 would be our low. So doing the derivative of this part, we have low derivative of high minus high derivative of low all over low square. Let's try to put this in a bracket. Okay, so let's try to insert this in our equation. Okay, so let's try to clean this up first. Our symbol for the derivative, we have the subscript. Okay, so again, this is low derivative of high, derivative of x minus 1, minus high, derivative of low, you have x plus 1. Alright, so this part here is the derivative of this part here. Okay? Okay, so minus. Now as for this part, this is actually simple differentiation of these terms here. So this is a bit easy as compared to the other one. Okay, so again, if you're getting confused, you try to go back to the video discussion of this part. Try to take things slowly so that you could follow step by step. Okay, so for this part, we have derivative of x squared plus x minus 2. This becomes derivative of x squared is of course 2x raised to 1. I will no longer write 1 plus derivative of x is 1 and derivative of negative 2 is 0. So finally we have only this equivalent for this part here. Let's try to insert that one. Alright, so you have 2x plus 1 as the derivative of this portion here. Now let's try to perform the derivative of this part. Now derivative of x minus 1. Now the derivative of x minus 1 is simply, well, derivative of negative 1 here is 0. Derivative of x is simply 1, so therefore this is simply 1. So which means we could actually remove this part and leave x plus 1 as is. The same goes with this part of the solution. You have derivative of positive 1 here is 0 and derivative of 1 is 1, so this becomes 1 multiplied by x minus 1, so simply we could simply remove the 1 there and leave x minus 1. Okay, so to further simplify, we have, of course, x minus 1, we could drop the parenthesis here for x plus 1, while we could distribute negative 1 for x and negative 1, so this makes it negative x plus 1. Right? So that becomes negative x plus 1. Now, of course, negative x plus 1 becomes, we could cancel x. And what is left here is we have 1 plus 1. 1 plus 1 is equal to 2. Alright? Now, what we can do with the second part here is that we could actually multiply using FOIL method the value between x minus 1 and 2x plus 1 and have this in fraction form. The same goes with this part of the solution. We could actually write this everything here into a single fraction. So doing that, we have just like what we see here. We could actually just remove the straight brackets. Now also, we could do the same for this part here by multiplying x minus 1 with 2x plus 1. So perhaps you could try performing first the FOIL method between x minus 1 and 2x plus 1. Okay, so perhaps you could do that. Okay, so 2 Okay, so doing the FOIL method, we have first x times 2x, so that would be 2x squared. Alright. Next would be you have 2x times negative 1, so that becomes minus 2x. Next is x times 1, that would be x. Next is negative 1 times 1, that would be negative 1. And we can write actually this one as 2x squared minus x plus 1. So, but perhaps you could replace first the expression for x minus 1 times 2x minus 1 with this expression. So multiplying that, this will no longer will appear. So you have this as 2x squared minus 2x plus 1 minus 1. Negative 2x plus x. Now, negative 2x plus x becomes negative 2 plus 1 is negative 1, so negative x. Okay? So, now, if we try to combine these two fractions here, remember, we have a complex fraction. We have a complex fraction, subtraction of fraction in the numerator, and this is also part of the entire numerator with having a denominator x squared plus x minus 2 squared. Now, to further simplify, what we can do is combine these two. Now, getting the common denominator between x, perhaps we could try to remove first this part here and try to get the common denominator between x plus 1 square and x plus 1. Now, of course, the common denominator between x plus 1 square and x plus 1 is x plus 1 square. Okay, so try to recall your addition of fractions so that you could follow up on the step-by-step solution presented in this video. Again, after getting the least common denominator, what we do with the least common denominator is that we divide each of these fractions with the least common denominator and multiply the corresponding numerators of each of these two fractions. Doing that, we have x plus 1 squared divided by x plus 1 squared, that would be 1, times the numerator gives us the numerator. Alright? Minus. Again, how did we arrive with this expression here? Again, least common denominator, or LCD, divided by this denominator of the first fraction, x plus 1 squared divided by x plus 1 squared is 1. 1 times the numerator gives us the numerator. Alright? Minus. Next, you have x plus 1 square divided by x plus 1. X plus 1 square divided by x plus 1 is x plus 1. Let's try to copy that one. Times the expression for the numerator 2x squared minus x minus 1. Right? Let's try to put it here. Alright. Again, how did we arrive with this part of the expression? X plus 1 squared divided by x plus 1 is x plus 1 times the numerator 2x squared minus x minus 1. Alright? Now, the next obvious step is to distribute each of these two terms, then combine like terms. So doing that, what happens now to our solution is first here is you just simply need to distribute 2 with the rest of the terms here. So doing that, this becomes 2x squared plus 2x, and 2 times 2 becomes 4. Alright? Now next is we have here a distribution between x plus 1 and 2x squared minus 1. So in order to replace this, perhaps we'd write that the replacement. Let's try to distribute first the value of x with the trinomial 2x squared minus x minus 1. Okay, so doing that, we have 2x squared times x gives us 2x cubed. Alright, minus x times x is x squared. Alright, next is x times negative 1 gives us negative x. Alright, then plus, let's multiply 1 with the rest of the trinomial. So since this is only times 1, so simply the rest of the solution will just copy. Alright, so we just copy 2x squared minus x minus 1 in our solution. Okay, so you have plus plus 2x squared minus x minus 1. Alright, so let's try to have this in parentheses first. Okay, so let's try to replace this part with this expression here. Alright, now let's combine like terms. Okay, so of course 2x cubed has no partner, negative 2x squared and 2x squared on the other hand would add up, so that this becomes 2 minus 1. 2 minus 1 is positive 1, so this, we could write this as plus 1x squared and remove 2x squared. Since you have 2 minus 1 is 1x squared. Next is you have negative x is negative 2x. And finally, you have minus 1. Now, the next obvious step is to remove the parentheses so that this could be replaced entirely by this expression. Dropping the parentheses. As for the second expression, we need to distribute the negative sign to everything here so that this becomes plus. So that this becomes plus, and this becomes negative 2x cubed minus x squared plus 2x plus 1. Okay, let's try to drop the parentheses. Alright, and then finally combine like terms for this part of the numerator. We have, well, negative 2x cubed doesn't have any partner, so that leaves negative 2x cubed as is. 2x squared, negative x squared, so that becomes 2 minus 1, that gives us 1x squared. So let's try to drop 1 of the x squared and leave 1x squared. Okay, so 2 minus 1. Next is you have 2x plus 2x, that becomes 4x. Let's try to write 4x and drop the other 2x. And you have finally negative 4 plus 1, that gives us negative 3. So let's drop the plus 1. Alright, so rearranging, we could write this one in descending order or in ascending order, descending order. That would be negative 2x cubed would be in front, then plus x squared plus 4x minus 3 over x squared, x plus 1 square over x squared plus x minus 2x squared. Again, this is, try to notice that this is still a rather complicated, rather complicated fraction. So what we can do further is to simplify this by dividing these two, not necessarily performing the division, but writing it in into a single fraction, having a single expression for the numerator and a single expression for the denominator. So doing that, we can arrive with this form of the fraction equal to this form. Alright? So we're in, you get the reciprocal of the lower fraction. Of course, this is x. This entire expression here is over 1. You try to write the whole fraction in the numerator as is, multiplied by the reciprocal of this denominator. So what happens there is these two denominators would be written down as a single expression as a single denominator. Okay, so perhaps we could leave the expression here as our final answer. Now there are still items in the exercise, in the examples that were not answered. I am hoping that you will be doing the or applying the concepts that were supposed to be learned at this in this video lecture, and try to answer the rest of the examples on your own. Okay, so at this point, I'll be cutting now the video. Have a good day, everyone.